Hi, I'm Professor Frederic for Leymarie at Goldsmiths in computing, and today I'm giving you a short overview of a module offered in Term 2 after Christmas, Graphics for Games and VR and AR. This is a usual 15-credit module, and it's evaluated through Courseworks. Just a bit of about myself. So my background, I have done a PhD at Brown University in the US on shape modeling in 3D. I also did a Master of Engineering before that at McGill in Canada on computer vision and AI techniques. In between the two degrees, I did work in industry in geographical information systems in France. And at Goldsmiths, I launched a number of programs, including the computational art and the two masters in computer games, the MA and the MSc. Research-wise, I work on computer vision, graphics AI, and I also get involved in companies such as London Geometry. The course is structured in this fashion, so we spend time on main techniques used in computer graphics nowadays, including curves, how to model curves via interpolation. We'll look at main techniques such as Bezier and B-splines, and then we'll move on to apply such techniques to 3D surfaces. We'll also look at 3D meshes, which is an alternative to interpolation where you have millions of points or even billions, and you connect them, for example, using lots and lots of triangles. And how do you deal with this data and find, for example, little mistakes, little holes in your mesh? How can you fix that? Then we're ready for light rendering. So once we have good ways of modeling objects via curves and surfaces, we can look at how to render them. And we'll look at modeling light which intersects with surfaces, with different light sources, and we'll use also techniques such as Monte-Carlo photon maps. These comes from probability field. We want to make our techniques very efficient to render in real time multiple images, even videos. We'll move on to using physics to model fluids and use that to do effects like smoke, water, fire, etc., gases, all kinds of liquids, for example, with oil or things that are viscous. And then we'll move on to the last part of the course, and we'll look at what's happening nowadays in research and development, including the impact of machine learning and AI on graphics. So in terms more details on the assessment, two main courseworks, 50% each. First one is individual project. Last one is based on any topics we covered in class. Can be done in groups, little groups of 2 or 3. Just to give you a feel, so these are the sort of results that you could achieve by taking this module. So here, different types of light rendering. You see on the left here, ray casting and ray tracing that allows you to model transparency, multiple reflections, different types of surfaces. And on the right, you see basically two objects, but that are rendered in different ways by modeling how light intersect with these surfaces. Also, just to give you a feel again, for fluid simulation, so here 2 short videos, modeling water with lots of particles. So this is again the type of techniques we would explore, and you should be able to do this kind of application by the end of the course. So quite nice effects. Here's another types of effect where you model how waves behave. In particular, when you're near the shore, you have larger waves. So we can look at simple math to model this type of effect as well through the course. And again, you would be able to achieve this kind of rendering by the end of the course. So that's sort of the overview I wanted to present today. And I hope you'll take this module in the winter and I'll be happy to meet you. If you want to ask more questions about this module, you have my email, ffl@gold.ac.uk. See you soon in the winter. Bye.